Buddy, it's me. I'm gonna go ahead and do the last part of this bidirectional uh, shift registry, and basically, uh, I didn't want to necessarily do an entire bidirectional shift registry and go over waveforms and how they work 100% like that. Just because of the fact that it's so close to how the assignments go, I feel that in order to describe a bidirectional shift registry, it was important to show the waveforms. So this is a shift left, um, and when you're shifting left, you can see now why I did these vertically, because they line up. Uh, this being your bottom, and this being the top as far as the JK flip flops are in order. Uh, when you have a left shift registry, or when the bidirectional shifter is moving left, that is a low input, that's your zero. And when you start at zero, there's only room to go up. That's how I remember this. Uh, so you're starting at zero, and then you're going up the stairs. Um, the exact opposite will be on your shift right. So we'll do that real fast, which hopefully shouldn't be too difficult here. We're just going to kind of rewire this a little bit here. Okay. And so remember, this is your shift left, and your 0000 and 0001, 002, or 0011, 0111, and so on and so forth until it resets. This is your shift right, which is going to go um, in the opposite direction. We'll let it kind of run through so we can get a good place. And again, a little laggy, but okay, this is a good one. Here's a reset. So shift right, it's your high input on a bidirectional shift registry. Uh, so your high input being 1, and shifting right is going to go down. So you start high and work low. That's how you remember that. Uh, it's going to make a V here when it's going bidirectionally. So it can only go one way at a time. You can stop it, and and have different timings and whatnot. It all varies based on the input. Uh, just for symmetry, I went ahead and kept it simple as far as the input goes, with just keeping the clock. Um, so again, like I said, when you shift right, um, it's your high input, so you start high and work low. So we're at 000, and then we're 1 0 0 0, and then we're 1 1 0 0 1 1 1 1 1 1 1. So that kind of describes the shift right. So now that you know what shift left and shift right, um, shift registries look like, as far as waveforms, you can imagine that when you put them both together, what it's going to do, it's going to go down and then back up. And it's almost like taking this and making a mirror image of it and just flipping it over in a perfect setting. That's how it's going to look. Uh, so that is your bidirectional shift registry, kind of in a nutshell. And there's more to it. They can be read in series and parallel. You'll have some components that will do both. Your universal uh, your universal shift register is going to be able to do all those things. Let's see if we can pull one up here real quick. Let's see if I can remember what it is. It's all the way down here. There we go. And this is a pretty standard universal shift register. This can go both in a um, series and parallel inputs um, based on whatever you are wanting it to do. Of course, here's your Q outputs, and it's going to basically be taking both of these, adding them together. There is some logic involved with some and/or statements, or they can also be done with NAND statements quite easily as well. And based on your input, you're either putting a high input or low input, and you're going to get the same outcome here as you do here. So this is primarily when you're doing this what you kind of work with as far as the bidirectional shifter goes, and I use this one as an example because it will do both parallel and series input. The outcome is still relatively it's going to be the same. It's just how you put information in and how how quickly and how it's going to respond and things like that are going to be the major difference there. So this is that pretty much sums it up for the first half of the discussion. I appreciate you taking the time to watch.